Hello, my fellow YouTubers. This is Roy back again. What you're looking at is the moon to the left. That is Venus right there to the right. And right above it, I can see it. I don't know if you can see it, but it makes a triangle, is Mars. This is January 31st, 2017, the triangle. Venus, Mars. Wow, that's just so exciting. Alright, so we're going to walk back to my workshop. Tonight we're going to talk about some cool stuff because having this pipe that goes down the ground allows me to do different types of electricity versus like regular like magnetism. And what I'm talking about is charging by contact. So a light, slight contact, more like induction, like a close contact. So the pipe connected to the ground runs in the ground about 6 feet. Okay. If we put a positive charge in the pipe, we will be able to pull a negative. We'll bring negative out of the ground and be able to pull negative out of it. So we'll see a negative charge come out of this coil onto this right here, this voltmeter, and then you'll see that little black right there show up, and that's be a negative charge. Then when the magnet passes, okay, so here we are, we're moving, okay. So what we're doing here is we're changing the pipe's charge, okay, and in return, the ground that's connected to the pipe is supplying the charge back in the system. So whatever draw we put on this, we're going to see more coming out because of the massive amount of metal we have here that Ed has with the chains and everything else that's going on there. We'll be able to pull a lot. And for instance, let's go here and come over to the periodic table. All right, let's go over to my friend Mr. Fe Iron, number 26. So iron, 26. So it has 26 protons and 26 negatively charged inside the atom. Okay? Negatively charged little guys. In a iron, there's 4 negative charges. Per. So I believe you would have 20. So you go up to that number up there and you'd say Fe is number 26. So it has 26 electrons, 26 protons, 26 neutrons, neutral. So it would be 26 times 4 would be how many electrons, negative charges are bouncing around in that orbit. So a lot of negatively charged material, iron. But what you have here is connected to the ground. So now everything that's touching the ground is neutrally charged. So that massive amount of iron I have there as a pipe is now neutrally charged. This motor block, the flywheel, and the handle and everything else is not on the ground, but its edge was. So we're going to connect a cable to that and ground that block. So that block becomes a neutrally charged, okay? Very important. So every time you see this side here, what is that? Is that a positive or negative? Let's see if we could find out real quick what we have here. So for the compass, we got a south and a north. Okay, so when we go south, we'll be putting a negative charge out. Let's look at the voltmeter. All right, see the negative show up. Now we're going with the south. Now we're going with the north. That's going to put a positive charge. So we see it go off, go on, go off, go on, go off, go on. So we're in the pipe where oscillating this enormous amount of negative energy that we can have come out through the copper coil. And this is just a start because it's unlimited on how much charge you can get out of this thing once you get this all put together. You know, a couple good things I like to do is build myself an electroscope, and this way I can see this and the materials show up, whether it's a positive or negative charge. So that would be cool too. And whatever we present in this pipe pretty much is what it's going to require from the ground, but the opposite. So interesting stuff here. Another thing I wanted to talk about was if you look in Ed's box, there's two cables that run down the side here. They're electric cables. There's no need to have electric cables. He's got, if you look at the video that's out there on YouTube, he's got a cable running down the side, the chain. There's a rod running through, comes out the other end, I believe. And that's how the chains are connected to the rod. Or he's in a foot. I don't know. If he's got a break in the middle there, I don't know. But he's got a cable coming down. So we're going to talk about that cable that comes to that box. And he could have the cable running down and coming and running across the ground, going back to his workshop if he was doing something with that box. Or he could be sending electromagnetic waves over to it, and it's sending down the cables some electrostatic type of energy that would take that rock and change its poles. And by changing its poles in that rock would make the rock a lot lighter, easy to manage. You can see him, he's over here, he's almost underneath it, moving it. So in order to do that, you would get into the things that we're talking about here with Edge Wheel. It's about not using the magnets for make electricity, but it's more of enticing the pipe to begin a process of diverging, and we'll be taking energy from the ground based on what we present in the pipe, which has a lot of electrons in this sucker. So it's able to take that negative energy and bring it up, or we could put a positive energy. Well, positive, we get the negative back. We put a negative energy in it. It's going to repel the negative energy in it, and it's going to pull all the electrons up through the wire. They're going to come out, but they're going to come out into the PMH, and the PMH separates the poles. So now you have two electrostatic poles generating, and them going into the coral rock, I would think that there becomes a if you had the rod going through the rock, and you had the electrostatic two different poles coming down, or if it's one pole and it's just a loop, which is just probably a loop, because once you stop the flow, then it would just disappear and become weight again. So let's just say you have come down, it comes down, and it loops back up to the top. Say if this had to have, based on itself, um, just take all the electrons out of it. So basically, it has so many electrons, so many protons, so many neutrons. Um, it would push, if you positively charged it, it would push the electrons over to one side, and it would push them in an area. Then if you negatively charge it, it would pull the electrons. Well, if you positively charge it, it would pull the electrons out of this rock into the material that's right in front of it. That would be the metal, or into the iron. The iron that goes through it absorbs all that energy, and then the rock would be lighter because half its weight is gone. It pretty much, when you take out when you take the energy from there, I believe that you're changing the each atom that's in there. But all right, guys, leave your comments. Mr. Ed Leedskalnin. What the hell is he's a young man over here? What the hell is he thinking? Mr. Ed Leedskalnin. He was young there. He had it built. He was already done building that stuff over there. Look how old he is here. He's old as hell. Old as hell here. Wasn't making electric with this wheel, guys. This wheel is special. Very special. All right, you guys, take it easy.